Use a vector method to find the minimum distance between the point P with position vector 148 and the line r is 232 plus lambda 11 negative 1. So if this is our line, and we say the point is here, and the coordinates are 1, 4, 8, the minimum distance is when the line from the point to our line is a right angle. Now the direction of the line is 1, 1, negative 1, and a general point on the line would have coordinates 2 plus lambda, 3 plus lambda, and 2 take lambda. That means that this vector here would be, so we want to go from 1 to 2 plus lambda, so that would be 1 plus lambda. We want to go from 4 to 3 plus lambda, so that's negative 1 add lambda. And from 8 to 2 take lambda, so that's down by 6 and also down by lambda. So what we want is the particular value of lambda at this point, and we can find that because we know that the dot product of this and this must be 0. So we have 1 plus lambda, negative 1 plus lambda, negative 6 take lambda, dot 1, 1, negative 1 is equal to 0. So that's 1 plus lambda, add negative 1 plus lambda, and then take away negative 6 take lambda is equal to 0. So that's 1 plus lambda, take away 1 plus lambda, add 6, add lambda is equal to 0. So over here we've got 3 lambdas and 6. So 3 lambda equals negative 6, lambda equals negative 2. Now the vector just here is this vector, and what we want is the distance, which is the length of that vector. So if lambda is negative 2, this vector becomes negative 1, negative 3, and negative 6 take away negative 2, so that will be negative 4. And so our distance is just going to be the square root of 1 squared, add 3 squared, add 4 squared. So that's the square root of 26.